Transformations of complex numbers, example 1, involving both multiplication and addition. We're asked to plot Z1, Z2 and Z3 on this Argand diagram. So I'm placing these in the appropriate places. And we'll label them also. So our Z1 is 3 plus 2i, our Z2 is 3 plus 3i, and our Z3 is 4 plus 2i. In part 2, we're being asked to plot on the same axis 3 times Z1. I could either multiply Z1 by 3, or I could construct this using a compass and a ruler. 3 times Z3 is the number that has the same argument, but the modulus is 3 times as big. So I'm enlarging the number by 3 using the compass. So we see when we multiply out, or whether we construct using the compass, we will get the same answers. When we enlarge a number by 3, it just means the modulus is 3 times longer. And I'll plot these points. So we have a choice how to approach this. In part 3, we're to plot the rotation Z1 multiplied by I squared, and the same for the other 3 values, Z2 and Z3. I squared is -1. So we could either multiply Z1 by -1, or a rotation of -1 means we rotate it 180 degrees around 0. I could construct this using a compass, as you see in the picture here. Whether we rotate by 180 degrees, or if we multiply the complex number by -1, we will get the same answers as we see here. We're asked then to plot these points. It is worth noting that when you multiply a number by -1, its size or its modulus has not changed. In part 4, we're told that the complex numbers 4 minus I, 4, and 5 minus I are images of Z1, Z2, and Z3. Firstly, I'm going to just draw out each of these. I'm going to plot them in our Argand diagram. And what we notice is when we plot these two diagrams, we could see that a translation would map Z1, Z2, Z3 onto this. So there's a shifting. We'd understand this, that there's an addition taking place. We see that Z3 would be mapped onto 5 minus I if we add 1 to it and subtract 3i. So the answer to the question is if we add 1 and take away 3i, so A is 1 and B is equal to 3i. We could also take a numerical as well as this geometrical approach to this. We could ask ourselves the question, for instance, what would you add to Z1 that would map it on to 4 minus I? So in other words, Z1, which is 3 plus 2i, if we add A plus BI to this, the answer to it is going to be 4 minus I. So if we take this equation and subtract 3 and subtract 2i from both sides, we would see that A plus BI must be equal to 1 minus 3i. So we get the same solution numerically as we got geometrically. What we should have learned from this question is that multiplication may involve scaling and or rotating, and that's the kind of transformation that happens in multiplication. And when we add complex numbers or add any numbers, it's a shifting that takes place.